Hey there, welcome back to our channel. In today's video, we're diving deep into the fascinating world of Web3, a new internet paradigm that's set to revolutionize the way we interact with the digital world. To fully understand Web3, let's first take a trip down memory lane and explore the evolution of the internet. Web 1.0, the first generation of the internet, also known as the static web, emerged in the early 1990s as the first stage of the internet. Was a read-only platform that primarily featured static web pages. The user experience was limited to browsing and reading content, with minimal interaction. The second phase, Web 2, also called the social web, started in the early 2000s and transformed the internet by making it more interactive, dynamic, and user-centric. Web 2 enabled people to create, share, and collaborate on content, leading to the rise of social media platforms like Facebook, Twitter, and Instagram, user-generated content sites like YouTube, and e-commerce giants such as Amazon and eBay. Although these changes greatly improved the online experience, they also led to a few companies controlling data and users depending heavily on these dominant players. This has caused concerns about data privacy and monopolistic behavior. Currently, we're transitioning from the end of Web 2 towards the beginning of Web 3. Web 3, often referred to as the Semantic Web or Decentralized Web, is the next evolution of the internet. It aims to create a more open, secure, and user-centric online experience by leveraging decentralized technologies like blockchain, distributed ledger technology, DLT, and smart contracts. The core purpose of Web 3 is to address the challenges of Web 2, such as data privacy, centralized control, and lack of interoperability between different platforms, and to empower users with greater control over their data and online interactions. In Web 2, control largely lies in the hands of a few centralized organizations, often referred to as big tech or Silicon Valley giants. These companies, such as Google, Facebook, Amazon, Apple, and Twitter, have amassed enormous power over user data, digital advertising, content distribution, and various online services. Web 3, on the other hand, aims to distribute control among its users and network participants by leveraging decentralized technologies like blockchain, distributed ledger technology, DLT, and smart contracts. Instead of relying on centralized intermediaries, Web 3 envisions an internet where users have direct control over their data, assets, and online interactions. This shift in control is facilitated by decentralized platforms, such as decentralized finance, DeFi, services, decentralized autonomous organizations, DAOs, and decentralized applications, DApps. Web 3 is built on several core technologies, such as blockchain technology is the backbone of Web 3. It's a distributed ledger that records transactions and data across a network of computers, also known as nodes. Each node maintains a copy of the ledger, ensuring transparency and redundancy. When a new transaction is made, it's grouped with others into a block. The nodes in the network then validate the block using consensus algorithms like proof of work or proof of stake. Once validated, the block is added to the blockchain, creating a permanent, tamper-resistant record. Blockchain serves as the foundation for many Web 3 applications, including cryptocurrencies like Bitcoin and Ethereum, decentralized finance, DeFi, platforms, and non-fungible tokens, NFTs. Bitcoin, the first and most famous blockchain, is a decentralized digital currency that allows users to send and receive payments without intermediaries like banks. Cryptography is another crucial component of Web 3. It uses mathematical techniques to secure data and communication, ensuring privacy and data integrity. Cryptography is used in Web 3 for various purposes, such as 1. Encrypting data, protecting sensitive information from unauthorized access. 2. Digital signatures, verifying the authenticity of digital documents or transactions. 3. Secure communication, ensuring privacy and communication between users and systems. The Secure Socket Layer, SSL, and its successor, Transport Layer Security, TLS, are cryptographic protocols that enable secure communication over the internet. They're widely used in online banking, e-commerce, and other sensitive applications. Smart contracts are self-executing contracts with the terms of the agreement directly written into code. They automatically execute when specific conditions are met, eliminating the need for intermediaries and reducing the potential for human error or manipulation. Ethereum, a leading blockchain platform, enables developers to create and deploy smart contracts for a wide range of applications, such as decentralized finance, DeFi, token creation, and decentralized applications, DApps. For example, imagine a simple smart contract for renting an apartment. the tenant and landlord agree on the terms, such as rent amount, duration, and deposit. Once both parties sign the contract using their digital signatures, the smart contract automatically transfers the deposit and rent from the tenant's account to the landlord's account, according to the agreed upon schedule. If the tenant decides to leave the apartment early, the smart contract would calculate any remaining rent and refund the deposit accordingly. This process eliminates the need for manual intervention, streamlining the rental process and reducing potential disputes. Decentralized storage is aiming to replace traditional centralized storage systems with a distributed network of nodes. This approach provides multiple benefits, including improved redundancy, security, and user control over their data. The Interplanetary File System, IPFS, is a decentralized storage protocol that enables users to share and store data across a global network of nodes. It uses content addressing, meaning files are identified based on their content rather than their location on a specific server. This ensures data integrity and makes the system more resilient to censorship and data loss. Peer-to-peer networking is a decentralized network architecture that allows data to be shared directly between users without relying on central servers. Peer-to-peer networks are highly scalable and resilient, as they distribute the load and storage across multiple nodes. BitTorrent is a popular peer-to-peer file sharing protocol that enables users to download and share large files efficiently. It breaks files into small pieces and distributes them across the network, allowing users to download pieces from multiple sources simultaneously. Decentralized applications, DApps, are a new type of software application that leverages decentralized networks, like blockchain, to operate. Unlike traditional applications, which are hosted and controlled by a single centralized entity, such as a company or organization, DApps are built on top of decentralized platforms that distribute data and control across multiple nodes or participants. Improve security because they don't have a single point of failure, making it harder for hackers to compromise the entire system. Use smart contracts to automate transactions, reducing reliance on intermediaries and lowering fees and inefficiencies. Some real-world examples that showcase its potential. Decentralized finance, DeFi platforms, like Uniswap and Aave, allow users to trade cryptocurrencies, lend and borrow assets, and earn interest on their holdings without relying on traditional financial institutions. Non-fungible tokens, NFTs. NFTs represent unique digital assets like art, music, and collectibles. Platforms like OpenSea and Rarible enable creators to mint, buy, and sell NFTs, opening up new revenue streams and opportunities for artists and collectors. Decentralized autonomous organizations, DAOs. DAOs are organizations that operate without centralized control, using smart contracts and blockchain technology to enable transparent decision-making and resource allocation. Examples include MakerDAO, a decentralized lending platform, and Aragon, a platform for creating and managing DAOs. Decentralized social media. Platforms like Mastodon and Steemit offer decentralized alternatives to traditional social media, providing users with greater control over their data and more equitable reward systems for content creators. Just like any new technology, Web3 has its own set of risks and challenges. Because Web3 is decentralized, it's hard for governments to regulate it. It can be difficult to enforce laws and hold parties accountable for their actions. This can cause problems for users, developers, and businesses. To stay safe, everyone involved should stay informed about new rules and work with policymakers. While Web3 emphasizes user control and ownership of data, it also raises privacy concerns. Public blockchain networks, for example, store transaction data in a transparent and accessible manner, which can potentially expose sensitive information. Smart contracts can have errors or weaknesses that hackers can exploit. If smart contracts are poorly designed or implemented, they can cause problems. Users should be cautious when dealing with unknown or untested smart contracts, and developers should follow best practices and provide clear instructions. One well-known example of a smart contract vulnerability that was exploited by hackers is the DAO, Decentralized Autonomous Organization, hack in 2016. The DAO was a decentralized venture capital fund built on the Ethereum blockchain, using smart contracts to facilitate investments and decision-making. The smart contract that governed the DAO contained a flaw in its code related to the withdrawal function. This flaw allowed a hacker to repeatedly withdraw Ether, the native cryptocurrency of Ethereum, from the DAO without actually reducing the attacker's internal balance. As a result, the hacker managed to siphon off approximately 3.6 million Ether, worth around $50 million at the time, from the DAO's fund. As the internet continues to evolve, it is crucial to understand the potential impact of Web3 on our future. Web3 promises to reshape various aspects of our lives, from how we conduct financial transactions and manage our digital identities to the way we work and interact with each other online. It also has the potential to disrupt traditional industries and create new opportunities for innovation and growth. Understanding Web3 and its implications can help us adapt to the changing digital landscape, make informed decisions, and participate in shaping a more decentralized and equitable internet for the future. Thanks for watching. I will see you in the next video.